Hello and welcome back to module number 4. In today's module, we are going to talk about a quick review of what we have covered, a quick one, and then we're going to talk about research methods. Why? Because it appears in both text, the text and the upcoming text. So I want you to have better understanding. I will also talk about statistics, descriptive statistics, and then I will talk about analytical patterns as discussed in our textbook chapter 5. So that will give you indication where we're heading. And then I would like to continue to explore Tableau and make it more concise. I think I did a bad job in a previous module with regard to what I gave and how to apply. So I hope this review will be more in-depth. So let's begin. I want you to remember that in the beginning, in in module number 3 and module number 2 and 3, we talked about the foundation, the idea of how do we apply data to visualization and what do we do with the data in order for us to convert it into visualization. We talked about comparing, we talked about sorting, we talked about adding variables and so on and so on. But I think I want you to have it back in your mind with regard to the visualization. What is the added value to visualization when we are applying statistical analysis to it? So today I'm going to talk a little bit more about the visual aspect, the statistical aspect. And in statistics, we often talk about research method as the framework for our work. So what does it really mean? I'm going to talk about two frameworks that often researchers apply, qualitative and quantitative, and what does it mean when we go out and dig for data, how it apply. And then I will talk about statistics, and more specifically I will talk about descriptive statistics. So in reality, when we are being called researchers, we go out and we have a methodology that help us to measure things, human, etc., in order for us to report on the result of our study. I'm sure that most of you will do the same thing in your own work or as you continue your education. So basically, we have quantitative methodologies, qualitative methodology, and mixed methods that combines those two together. In qualitative, which means the issue of providing or focusing on making sense or provide interpretation to social or human phenomena, is the key component, which means that we go out and we are seeking to understand data or by observing or collecting something that involves in everyday life, and usually it involves a field work. So it is low descriptive data, it's more vocabulary that the human use or the subject involved or provide us, or we collect that type of data in order for us to do that. So the idea here is that we are trying to come up with a new phenomenon, a new way to integrate or establish the idea of data collection. So we usually it's more humanistic approach, which means a lot of philosophy, and we are trying to develop what is called grounded theory in order for us to come up with new ideas and new way for us to understand the nature of human behavior. In comparison, and it's big comparison, in quantitative research, we're talking about, and the unit of analysis, it's not human interpretation, but it's all about amounts, about frequency, a degree, values. And the idea here is that statistical use of statistical is being used in a more precise and objective and based on a model in order for us to apply. So the overall platform is usually all about the procedures that is very precise, and any researcher can follow our steps and conduct his or her own analysis based on our study in order for him to repeat those results. So it is based on the idea of we are trying to search for something, starting with something that we are familiar with. We have very defined dependent and independent variables, and dependent is the one who dictate on the independent variable, and I will talk more about that throughout the semester. We have the idea of descriptive, and we are trying always to see if we can have causality that cause and effect and what it is and how to measure that. And the idea here is that in both platform or methodologies, we have assumption that we are trying to measure, but the issue is the purpose and the role of the design is a little bit different in each paradigm. And the idea is that in qualitative, it's much more flexible and much more dependent. In compared to quantitative, it's much more it's not flexible as qualitative. You have to document every step on the way in order for you to produce the work and be able to apply to it. So again, this is the way for us to justify if we are doing the right thing and apply it. Statistics is the idea of collecting or analyzing and ability to apply or provide interpretation to the data that we collect and help us to make better decision. So the idea is, why do we need analysis? Because, as I said in module number 1, it allowed us to assess or to formulate alternative course of action in order for us to understand what we are doing. In statistics, there's 2 branches of statistics, and usually there's also the predictive or statistics or modeling, but the foundation or the key component of statistics is usually descriptive and inferential. And in descriptive, we are collecting or summarize the data. Inferential, we usually talk about how it reflects on the population based on a sample that we take. And predictive is the idea of come up with a model that help us to predict the probability of an outcome. So descriptive, as I said, is the idea of summarizing, collecting and summarize the data in a platform that it is, in comparison to inferential statistics that we estimate the population and we measure based on hypothesis, and the hypothesis is usually a statement that we need to prove is it right or wrong in order for us to do that. That is a contradiction to the person in qualitative paradigm, where he is going out to search and without any definitions of what he is going to find. So again, the issue of the measurements, the issue of population, the issue of a sample is a key component in descriptive and quantitative paradigm, and this is really important element, and we will see the result of it in visualization. Why is the visualization of visual analytics so keen on the descriptive or statistical paradigms in order for to present it? So population, what it means, sample, what it tells, a reasoning for drawing a sample, and what it is. In a sample, we to have 2 types of sample, non-probability and probability, and each one of them provide us more way for us to collect data. However, in probability sample, in comparison to non-probability sample, it's much more concise, much more accurate, and the research is reliable on the subject. In non-probability, there is the issue of the sense of that the researcher do it for convenience, and that's what he got, and that's what he is going to measure. In comparison, in probability such as simple random or systematic, everything is counted, everything has to be verified in order for the user or the researcher, if he published the result, it will be open for investigation if this study is valid or not. So this is the issue that is really important. One of the things that we always make sure to understand or make sure that we fully comprehend is the idea of the data source. Where are we taking our data source? Some of you will, in your final project, will take secondary data from database or resource or a friend or agency that provide us. Example, data.gov is probably one of the agency that allowed us to download the data and be able to play with it. However, there is another type of data, which is we observe or collect or take it to the lab in order for us to do that. This is the first foundation of the data source. This is primarily the data set collection. When we go to the lab, we observe all the data collected, keep it very close in order for us to do that. Secondary is something that we found on the web and we do not know who handled the data and who is collected it. So the issue of data is really important. However, this is not the end, because type of data is also key ingredient to our analysis. Why? Because usually the data is classified into two parts: categorical data and numerical data. Categorical data is such as material political party. Today I am Democrat, tomorrow I might be Republican. I can change my identification, political identification, and it doesn't remain the same, and the same goes to categorical data. And this is something that the research needs to be aware of. Numerical data usually is divided into two parts: discrete versus continuous. Discrete is the idea of the number of children, and it's counted items. It's something that we can count on, and we are measuring the items that involve. Continuous is measure the characteristics. Example, the weight. Today I'm weighing 250 pounds, but if I will start exercising, I might lose weight, or I might use some other characteristics, but those are the things that we are usually counting for continuous. I know it's not a clear definition. I will try to make it more concise or more correct when we do that. So again, with the nominal, ordinal, numeric. Example, sport or nationality is numerical. It's the lowest level. Ordinal is the place ordered by noise, and numeric is the height of a person. It's much more. In that sense, nominal is the lowest level. It's the weakest form of the measurements. Ordinal is a little bit higher, which is the ranking. However, in the ordinal and interval, we do not have a true zero, and the interval is a little bit higher than the ordinal. And the highest level is the ratio where we do have a true zero, which means zero is a part of our equation, and this is considered to be the highest level that we have. One of the things that you will count, and you will probably hate it, is the idea of data. and the idea of that we need to be become aware of the data and how we clean the data and what does it consist of. And sometimes the data that we are taking from other people or other resource has mistakes that we need to fix in order for us to generate the visualization we want. So we have the idea of data cleaning, we have the idea of normalization, we have the idea that in data we need to do segmentation, and our textbook talks about segmentation quite a lot. And we have the idea of how can we, if we have a million row of data from the survey, how can we reduce the amount of data? One of the techniques is using a sample. So again, different techniques, different ways of doing that. I like to talk in this idea. I like to talk from a personal point of view. One of the things is I want you to do is keep track and communicate where you do your data analysis or cleaning up the data, because this is really important. Otherwise, if you will not do that, and that's why I'm so keen about you having a blog and report on your progress on your blog, is that it will be more transparent to other people what you do, and by doing that will keep you honest, but it will keep you up line of what you have accomplished. So this is what I'm aiming. This is what I will try to show you why is my path to visual analytics through the eyes of open source is so important with regard to transparency. Back to descriptive statistics, and descriptive statistics is usually divided into 4 parts. The shape is how the data shape. The variation is the idea of how the standard deviation can be displayed. Quartiles is dividing the entire set into 4 equal parts, and central tendency is the idea of collecting or analyzing the data based on a very simple statistical methodology: mean, median, mode. I also put the geometric mean, but that will come later on. I will repeat that when we will do some advanced statistics. So for now, let's look at mean, median, and mode. And the mean is a quite simple way for us to measure. It is the idea that we are trying to have a sample size, and we collect all the observed value, and we are trying to measure what it is. Basically, it gives us the common measurements of central tendency. So the idea here is that it might be accurate, it might be not accurate, or might represent extreme values, but in the case to the right, you see that it doesn't reflect well when one of the variables is high and compared to the rest. So this is something that we are always looking out and be very cautious when we are describing the mean as our main of analysis. Median is a little bit different. Why? What he does that is that he measured the middle number in the row, which means in this case it doesn't affect by extreme value. So in these 2 cases that I displayed to you in this example, there is the 10 does not affect the outcome. How to find the median? It's n plus 1 divided by 2, but it is not the number but the position of the ranking data in order for us to do that. The next is the mode, which is again most often used as the most frequent number. There is a problem with that, because some of the data set you will be experience has no mode. So what do? How do you embed the mode? You cannot, but some of it's part of the nature of the data, and it's good to know that mode it exists. Let's take a simple example of buying a house. We want to buy a house in near the by the hill near the beach, and the prices range from 2 million to less. And so what we can do is use descriptive statistics to find out the mean, the medium, and the mode in order for us to have a sense where the prices in this neighborhood range. And this is important. Why? Because it will give us better sense where the value is. Mean is usually used, but when you have outlier, it has a problem. The medium is also used, but it's not as sensitive to extreme. It doesn't count as the extreme. So one of the other way is to measure the mean is geometric means. And again, the issue of how to apply that, I will discuss this later on in the course. But another way is to divide the data set into 4 segments that are equal number of value per segment. So what we actually do is divide it into 25%, 25%, 25%, 25, which will give us Q1, Q2, and Q3. And usually those observations help us to sort the idea. The formula for quartile is usually quarter 1 is equal n plus 1 divided by 4. Quarter 2 is n plus 1 divided by 2. And quarter 3 is 3 multiplied by n plus 1 divided by 4. N is the number of observed values. So how do we find quartiles? Example, we have n numbers, in this case 9 numbers, and in this case quarter 1 is 9 plus 1 divided by 4 is equal to 2.5, and in this case it will be between 12 and 13 in order for us to say that quarter 1 is equal to 12.5. Okay, so the second way for us to organize the data under descriptive statistics is to look at variation, which means that the spread of the data as a direction for us to understand what it means. So the range is the simple way for us to do. What we do is taking the largest number in the data set minus the smallest number in the data set, and it will give us the range. However, the disadvantage of the range is ignore the way the data are being distributed in the data set, which can be a problem, especially when we have outlier, which might be a big asset or a small asset. In range, it doesn't give us any value. It doesn't help us to understand the data better. Interquartile is another way, which means that we can detect Q3 minus Q1, which will give us the way for us to calculate the middle number or the middle range numbers in a data set. So it will take the quarter 3 minus quarter 1 in order for us to do that. And by doing that, we are accounting for the data, but not counting for all the data in the data set. That might be a problem later on. The next is variance, which means is the average of square deviation of value from the mean. So the formula is quite simple. In this case, the variance is a square root, something that we will take out the square root of this formula in order for us to calculate the standard deviation. So we have the mean, the sample size, and the value of the value of the variables. And so in this case, this is how we find the standard deviation and what it gives us. A good example of the power of standard deviation is to see that in the three example, data A, data B, data C, the mean equal 15.5. However, if we will calculate the standard deviation, we will find that the data C, the standard deviation is the bigger one, and as a result, we need to be cautious about our summary or advantages. So each of the data is used in this platform. Each of the data set is used in the calculation. The values far from the mean are giving extra weight in order for us to make sure that we understand it. Okay, so now back to our textbook. And the idea of the chapter 5 in visual communication. So he talks about the idea of quantitative scale and the reference lines and region. The quantitative scale is the way for us to arrange scale to organize the data. For example, arranging the data from the lowest to the highest. Remember descriptive statistics? He just gave it another name for range. So this is another way for him to describe in a different set of words what descriptive statistics does for us. So, for example, let's take example that he provide in a textbook from 2014, the U.S. Department of Transportation report on the following observation of 1,700 motorcycles nationwide in a randomly selected road location. So they have found that they measured if those motorcycles, bikers, have a helmet, yes or no, and what they came up with. And the idea here is that they came up with a visual representation of bar graph in order for them to capture that the cry for help is that most of the bikers in their study did not wear a helmet or did not have insufficient helmet, even though the proper helmet had also part of the idea. So again, what is the axis, x-axis and y-axis? Why is it important to mark it? Is it discrete or continuous? I want you to leave it up to you to decide. Think about that. Is it what it is? And the idea is it categorical data, yes or no? So two types of, we need to talk about the x-axis. It's categorical variable, name of the categorical, and the y-axis is discrete quantitative variables. What are the units in it? So again, see how we sort the data in order for us to deliver it in bar graph and what it is entail. One of the things that he is claiming in his book throughout the book is that he claims that pattern chart is the best way for us to capture the data. I agree and disagree, but it's a way for us to look at that data set differently because it gives us another dimension. And again, this is something that I want you to think about. Which is the best platform for your visualization? And I hope this will keep you engaged in the idea of the final project, what type of visualization you're going to choose. Okay, so this was the first part with regard to the reading. But I want to go over some of you came to my office and we discussed about analytical patterns and what is smooth and rough patterns and time series. And so I added to module number 4 because I thought this is really important subject that we need to discuss. So in chapter in the module number 1, I talked about the visual vocabulary, that points, lines, coordinate system, numbers, symbols, words are part of our vocabulary. But what about the smoothness and the roughness of the graph as it represents so well in bar graph? The data can be classified based on how smooth or how rough it is, and how the line curve shape the data that describe the idea. So the rough is when we have a lot of outsider that are outside the main stream, and usually we are talking about unusual values that can be caused by inaccurate data entry or extreme values or behavior of person that unfit to what we have observed so far. Those usually are considered to be unusual values that we need to do that. When we talk in statistical analysis, we talk about patterns that we find. We usually talk about the link between two variables and how they are combined or present in patterns with regard to comparing groups, comparing variables, and what statistical analysis associate with that. However, and this is where I come up with my big hand and show, in visualization, these patterns can be our asset to what we are doing. What does it mean? We can show patterns in the data set using a standard bar chart and provide additional insight to the data itself. Example, in this idea of patterns in the data set, this is an example. Not only do I show the data set who is the leading set in the bar chart, but the creation of the scale, the percentage inside, show us another dimension to the overall performance of the visualization or the analysis on it. I'm going to bring another element into our discussion today, because some of you, and in past, some of you said to me, and I try to match to your expectation about patterns, and they said that in the previous classes and in high school, usually the patterns were associated with time series. So let me define what is a time series and why patterns in time series are so important. So time series is usually the time is part of our analysis of what we are trying to match. We are trying to measure if the variable changes over time and how time play part in the overall performance. In techniques in time series, we have different techniques to apply it, and he outlined several techniques. Each one of them has its own value and its own core attributes. Let's start with single moving averages. It's a technique in statistics, which is a moving average in calculation to analyze data points, and usually the visualization, it's much more powerful if I will write you to the result of single moving averages, because you will get lost in the way. So the idea of visualization is the powerful and how we can capture it. Another way that he talks about is creating moving averages, and again, this is usual in business, that they are usually counting the how the flow of mortgages and loans are floating, and they usually calculate the moving averages. And again, this is one of the things that we look at. And another way is the smoothness of the components and how it apply. Another way of looking at time series is the idea of invert time series to idea of observe observe the data, the time in increments way, which means that we are applying it to predict what will happen next and add additional dimension to it. And again, this is a forecast in order for us to do that. The basic 6 design patterns in time series is outlined by a textbook. The trends, the range, the circle, expectation, and so on. This is important because again, we are trying the textbook, and the textbook that we'll read in this class is about way for us to create vocabulary that will help you to create better visualization. In the end, when you will ask me what is my objective, is to give you better vocabulary for you to create better visualization. One of the issue is trends. It is the overall tendency of a series of value to increase or decrease. So this is a way for us to capture it in time series. Another way is the idea of change over one point in time. And again, this is the way for us to capture one point in time in order for us to be more accurate, using visualization to make the case stronger case. And again, applying more strategic visualization techniques in order for us to do that. Range of change, and again, I will let you read it for yourself, because again, this is good points that I want you to take into account with regard. One of the things that the reason that I chose this book is the idea of best practices in time series display. He laid out 5 types of visualization: line graph, bar graph, dot graph, radar graph, and heat map. And he gives the rationale for why is it the best practices. The line graph is usually created by a plot and usually has a background in order for us to see how the time is being played in order for us to display the overall performance of the data. Radar graph is also very popular, and it is a little bit tricky because sometimes or some people do not have a sense of a clear vision of what it is. However, and from my point of view, it is very aesthetic, pleasant, and help us to capture that. Heat map is a very popular, and we will learn about heat map later on in the semester, and we will learn how to create a heat map. And this is a powerful tool, and especially when the data is so overwhelmed and does not have a central tendency as descriptive statistics. Heat map help us to understand better way. He outlined for us the best practice of time series, and again, this is something that I want you to start thinking about and try to be applied. I summarize all those components, and I hope that you will go over that and try to see what it entails, just to make sure that we are in the same thinking with that regard. Okay, so now I want to move to the second subject, and the second subject that I want to talk about is the idea of Tableau. And I feel that I did not give you a good sense of Tableau and what it is. I am a little biased against Tableau, and I do apologize, but again, Tableau is a very easy way to do that, and it allowed us to have dimension and measurements, and by doing that, it allowed us to create filters that allowed us to create filters to the data itself. Instead of working on the Excel sheet or the spreadsheet, it allowed us to do that on the Tableau platform itself in order for us to do that. I'm just going to open just a second the module itself to outline the issue that I want to show you. And the issue is that Tableau give you a very good sense, better than any other platform that we're going to cover in this class, about how to start and how to apply and how to develop it. And one of the things that they outline very well, better than I can, basically, is the working place. I did not go over that, and this is my fault. But again, it shows you what is your workplace, where is the dimension come into place, where is all the icons that they have inside. One of the things that is really important, and I need to emphasize it again and again, is the dimensions area and the measurements area. This is a great review of that dimension and what does it entail, how can you manipulate the data. One of the pages that I gave you is the idea that what I want you to do is look at data set. I gave you an example of a data set that I found in data.gov. It is a monthly module of time series. This is a large data set, and if you look at that, there's a lot of variables. What I did was I gave you the file itself, and then I clean it in order for you to work on it. But I want you to have a sense that this is part of your job as data visualization person, to clean the data, to be able to apply it. And what I did was I took it to Tableau. So I have a sense, and this is where the second time work with a data set to filter or to organize the data, and it give you quite directions of how to apply that. Those not be a good, and so you can remove each variable that you take. So you can have year, you can have the type of service, and you can have, so he already giving you dimensions and how to measure that in a sense of what is it entail. And so you can add and play with it. And again, this is the beauty of a Tableau, that he give you dimension of how to apply. You can add colors to it. You can add size. You can have labels, and you can have more details. And again, module number 4, go through every step in order for you to do that. And I want you to experience. I want you to download, if you don't like my data set with only 6 variables, you can download a different set and play with it and just create your own visual analytic display of the data and describe what you encounter. What is the problems that you encounter to cleaning the data, to organizing the data based on dimensions and based on the variables. How did you decide that process? So this is all for now. I hope you enjoy that, and I will see you next time. Until next time, have fun.